Hello, my name is Arniki Dinaliu, and my auditing is Muhammad Shadawi bin Matumbar, Eva Sharon Lee Marcellus, and Norman bin Abdul Rahman. Today we are going to discuss about how to apply the technique of integration. First, let me explain what this integration means in mathematics. Integration actually is a fundamental concept of calculus that deals with finding the area under a curve. Integration, also known as the reverse process of differentiation. In differentiation, it helps us find the rate of change of function, while integration helps us find the accumulation of quantities. Now let's move forward to my group's topic, which is area under curve. To find area under curve, we can imagine dividing the area into many thin rectangles and summing the areas. In short, as the width of these rectangles approaches 0 and the number approaches infinity, the sum approaches the exact area under curve. The formula for area under the curve y equal to f bracket x bounded by the x-axis and the lines x equal to c and x equal to d. So the full formula is this.
For part A, we ask to find the area under the curve y equal 3 plus 2x minus x squared from x equal minus 1 to x equal 5. Since the function crosses the x-axis at x equal minus 1 and x equal 3, we only integrate from minus 1 to 3 where the curve is about the x-axis.
So we're going to find solution for question 2a, where we're going to calculate the area of the enclosed region. The key point of this question is where enclosed region between the curve is y equal 3 plus 2x subtract x squared, while the x-axis in between is x equal negative 1 and x equal to 5. We're going to insert all the equation into one equation using formula of a equal to r integral b and a bracket y dx, and it will become integral 3 negative 1 in bracket 3 plus 2x subtract x squared dx. After that, we're going to integrate it into 3x plus 2x squared per 2 subtract x cubed per 3, and the x-axis will be outside of the bracket where the upper is 3 and the below is negative 1. After that, we're going to replace all the x with 3 and negative 1, just like in the calculation that I have done just before. After that, we will go in the first bracket, we will get 9 plus 9 subtract 9, and the second bracket we will get negative 3 plus 1 subtract 1 per 3, and after the calculation we've done, we will get 32 per 3 units squared. For the remainder, it is much better if you don't forget to integrate first, and much better if we do step by step for safety precaution.
For part B, we find the volume of a solid form by rotating the regression between y equal x squared and y equal x plus 2 from x equal minus 1 to x equal 2. We use the method with the formula.
Next, we're going to find solution question 2b, where we're going to find the volume of the solid form. The key point of this question is region enclosed by curve y equal x squared and a line y equal x plus 2. The formula we will use is b equal pi integral b a y squared dx. So the x-axis we haven't got, but according to this diagram, we can see the x-axis is -1 and 2. So for our equation, our full equation is pi integral to -1 in bracket x plus 2 squared subtract in bracket x squared in bracket again squared dx. So we're going to do some mathematical calculation, and we got pi integral to -1 in bracket x squared plus 4x plus 4 subtract in bracket x squared dx. Next, we're going to do some integration, and it became pi integral to -1 x the power of 5 per 5 plus x cubed per 3 plus 2x squared plus 4x. So after that, we're going to replace all the x with 2 and -1. So in this calculation, we will get pi in bracket 148 per 15 plus in bracket 32 per 15. And then after that, we're going to add it into 1. So in the final answer we got is 72 per 5 pi units cubed.
Integration is used in engineering to study how things change, rate of change, finding velocity, acceleration and flow rates. Optimization is designing system for maximum efficiency or minimum cost. For example, mechanical engineering, the velocity is the derivative of displacement with respect to time, and acceleration is the derivative of velocity. In short, differentiation helps engineer predict, design and control railway system. That's all. Thank you.